When black holes collide in space, it's a cosmic dance of unimaginable power and violence. Picture two of the most extreme objects in the universe, each with gravity so strong that not even light can escape, spiraling towards each other in a final, cataclysmic embrace. As these celestial titans draw near, they begin to orbit each other, creating a swirling vortex of spacetime. Their immense gravitational fields interact, causing ripples in the very fabric of the universe. These ripples, known as gravitational waves, spread out across the cosmos at the speed of light. The closer the black holes get, the faster they spin around each other. In their final moments, they're whirling at nearly the speed of light. The energy released in this cosmic collision is mind-boggling. When the supermassive black holes merge, they can release more energy than all the stars in the observable universe combined. But here's the kicker, we can't see this spectacular event with our eyes or even with the most powerful telescopes. Black holes, true to their name, emit no light. So how do we know when they collide? That's where gravitational waves come in. Special observatories on Earth, like LIGO, can detect these spacetime ripples, giving us a sound of the collision. In some rare cases, the merger might produce a visible flare of light. This happens when the black holes are surrounded by swirling disks of gas and dust. As they collide, this material gets superheated and can emit a burst of electromagnetic radiation across various wavelengths. The aftermath of a black hole collision is equally fascinating. The two black holes combine to form a single, larger black hole. This new behemoth settles down by emitting more gravitational waves in a phase called ring down, like the fading peal of a bell. These cosmic collisions aren't just spectacular, they're crucial to our understanding of the universe. They help shape galaxies, influence star formation, and provide tests for Einstein's theory of general relativity. Each detection brings us closer to unraveling the mysteries of gravity, spacetime, and the evolution of our universe. So, the next time you look up at the night sky, remember, somewhere out there, black holes are colliding in silent, invisible explosions, shaping the cosmos in ways we're only beginning to understand.